the Artifact aggregate service support provides you a possibility of treating multiple services as a single service. And this is convenient when your constructor list gets out of hand. So let me give you a very small and very synthetic example of where you might encounter this. So suppose you have a bunch of services. So I'll have a public interface iService1 like so, and then I'll just duplicate this. Let's suppose you have 4 different services, 1, 2, 3, and 4 respectively, and let's suppose you have 4 concrete classes which implement those services. So you have public class, class 1, which implements iService 1, and you have so on for 2, 3, and 4 respectively. So 1, 2, 3, and 4, iService 2, 3, and 4, and then what you have is you have some sort of component which actually uses all of these. So you have some kind of consumer. You have a consumer class, and the consumer class absolutely needs all those 4 services. So what does it do? It does the typical thing and adds a couple of fields. So we have iService1 called service1, and then of course I'm going to duplicate this, and we'll have 1, 2, 3, and 4 respectively, and we'll have service 1, 2, 3, and 4, and then you make a constructor which initializes all of those fields so that you can actually use constructor injection in the container. Now it's okay, but imagine if it's not 4 but 20 different services. You might want to somehow group these together so that this whole API doesn't explode to infinity. You want compactness, and it is possible to get that using aggregate services. So the idea is that you take all the interfaces and you stick them into a single interface. So you have an interface called iMyAggregate service, and this interface has a couple of properties, get only properties, which actually expose the services. So you have a property of type iService1 called service1, which has just a getter, and you do the same for service 2, 3, and 4, 2, 3, and 4, and here we specify 2, 3, and 4. There we go. So instead of all this junk, instead of all of these lines of code, what you can do is you can try and inject an interface. You have iMyAggregate service, let's call it all services. I'll actually make it public. So we'll have public iMyAggregate service, all services, and then we'll make it injected in the constructor. Notice the constructor is a lot shorter because there's just one single argument, and the only question is, well, how do these get injected into iMyAggregate service, given it's an interface without a concrete class? And this is where the magic of Artifact comes in. But Artifact isn't enough, and whenever it isn't enough, what happens is Artifact interfaces with other libraries to make sure that it has the functionality it needs. Now in this case, the library we want is the dynamic proxy2 library from Castle, but we don't get to see it ourselves. Instead, if we go into the Nugget packages, the package that we want is called Artifact Extras Aggregate Service, and if you look at the dependencies, you'll see it depends on Castle Core. So there is your hint right there that it's using other libraries, not just Artifact libraries, but the end result is that we can start using this and get the dynamically generated class which implements the iMyAggregate service interface and which has all of these injected correctly. So let's take a look at how that works. So once again, var_cb equals new container builder. Now what we need to do is we need to register the aggregate service, and for this, using the extension that I have in my Nugget package, I say register aggregate service, and here I specify the type as soon as I get back to this, register aggregate service. There we go. So I specify the type as iMyAggregate service like so. In addition, of course, I want to register all of those concrete classes. So here I'll use something smarter. I'll do register assembly types. I'll get type of program.assembly to get the actual assembly. So here's the assembly, and I'm going to pick the types where their name is a class. So where t.name.starts with a class, and in addition I will implement all of them as their interfaces. So as implemented interfaces, so class 1 is going to implement iService1, class 2 will implement iService2, and so on and so forth, and then I will register the consumer class. That's important, and then we can start using it. So we can say, well, I can do it like this, cb.build, and I think I can do using, can I do using, there we go, var container. Yes. So here what I can do is I can resolve something on the container. So I can say var consumer equals container container.resolve consumer. There we go. And then I can start printing something from the consumer. So for example, I can console.writeLine, and I can say consumer.allServices dot, I can get service 3, and I can get its type name, for example. So let me first of all execute this just to prove that it does in fact work. All right, so we execute this and we get class 3, which is the type that actually implements iService 3, which we just accessed. So what is happening here? How does all of this magic work? Well, thanks to Castle's functionality, what it does is it looks at this interface here. It looks at the interface, it finds all the elements, and then it says, well, let's make a concrete implementation of this interface. Let's make a dynamic class, so a class which is built at runtime, which actually exposes all of these members, and whenever somebody wants an iService1, it actually injects the appropriate type. So iService1 gets injected as class 1, and so on and so forth, and all of these are provided by simply doing the appropriate type resolution whenever this dynamic class is actually accessed. And it's worth noting that it's not just properties which are actually usable here. What I mean is the following. Let's suppose that class 4 is special somehow. Let's suppose that class 4 takes a parameter. Let's suppose that we'll have a string name here, and I'll have a constructor which initializes this. Now here, maybe I want to get the service with an argument. So instead of having a property, I need a method. So here what I do is I say iService4, like so, and I say get forth service, providing a name, like so. And I'm not giving this an implementation. Now what will happen at the stage when a dynamic proxy is actually built is, once again, the dynamic proxy will see that we have some method here, and this method returns an iService4. So why don't we, whenever somebody asks for this, why don't we use the registration to actually build an object which satisfies the iService4 interface, and into its constructor we will provide any arguments which we actually find in this particular method. So this name here will be proxied over to the constructor of class 4. Let's see how this works. So what I'm going to do down below is I will get the fourth service. So let me comment this out. So I'll say console.writeLine. So we'll say consumer.allServices dot, and then I'll say get fourth service with the name test, and then I can once again get type, for example, and get the name. So in this case, I'm going to run this once again. We're not going to see the name itself, but we are going to see once again the type which implements all of this. So hopefully it makes it clear what's actually going on. So given the interface, which presents an aggregate service, the Castle functionality builds up a dynamic class which implements this interface, and whenever it sees anything that can be injected, it injects it using the correct rules, and whenever it sees a method, it will inject the result of that method using whatever is actually being passed in. So the kind of things that you get support for are obviously properties, as in get only properties, and methods, because, well, property setters and methods which are void, they make absolutely no sense in terms of the dynamic proxy approach here. But methods which return an injected type or a property which is read-only, that is okay, and that is how the Castle functionality and the artifact functionality work together to save you some space, because now you don't have to make these massive constructors whenever you have a consumer. You don't have to stick all of those methods. Instead, you can say, oh, here is my service, and why don't you give me all of the initializations automatically? And this is super useful.